It's getting recorded, right?
Yeah.
Yeah, we can start. So first is our like transpose matrix. We are given a matrix here, we need to return the transpose of it. And transpose, like flipping the rows with columns. Transpose of a matrix is matrix flipped over its main diagonal, switching row and the column indices of the matrix. So you can see this 2 4 minus 1 rows will become your columns, and again this row will become second column, and third row will become third column. So this is what. Yeah. So what is the approach like? Okay, in this.
Yeah, actually. So it is the only very different thing about this problem would be like if we had uh, the rows and columns not same, right?
Yeah, square matrix, non-square. You are saying.
Yeah.
Yeah.
So that's the only thing. If it is different, then what do we do? Or if it was just a square, we could use the same
In
matrix
place.
from the
Yeah.
input, right? Yeah,
Mm.
something like that. But the problem looks straightforward that way.
Mm.
So maybe just run through two loops for each and
Okay.
every this one, and then
Swap the off
swap.
diagonal.
Yeah, diagonal, and so that is.
Yeah, I want to share code.
No, actually, you
Okay.
can go.
So
Yeah.
yeah, I mean, this I was doing what you're saying, but this will work only for the square matrices. Like it will fail. Like I'm swapping Aij with Aji, running two loops,
Yeah.
rows, columns, and if as long as I is less than j, swapping Ij with Ji and Ji with Ij. But this will fail in case of non-rectangular matrix. I mean, sorry, non-square matrices. So for that, I think I just took extra. mm, yeah, I took a extra matrix. I mean, outplace I did this one. Took a extra matrix and just took the rows and going through each of the columns and just appending it to the, what do you say, to the given matrix.
Okay. Yeah. So that should work, but
Yeah, it will work. It will
yeah,
work.
it will
But the
only
other,
always have a
this will have a problem. So if somebody has done in place, like,
yeah.
that would be a good one. Like,
I don't think so this can be done in place because it's a different structure. Only thing we can do is if the rows and column are same, have an in place
then,
function. Otherwise, we have to go with this.
oh, extra space.
Mhm.
Okay. Yeah. Okay, then let's go to next or any queries. See. Go to the next one, I think. Mini parser. Yeah, mini parser. So mini parser is like they have given a nested list of integers which are represented as a string. We need to implement a parser to deserialize it, and each element is either an integer or a list whose elements may also be integers or other list. And we may assume that string is well formed. It's non that's the note. String is non-empty and does not contain any white spaces and only digits from 0 to 9, and this box braces and this, what do you say,
So
comma, and yeah, sure.
in the previous question, is it given that it is a square or something, or it can be anything?
Anything.
Okay. Sure.
Yeah.
Yeah, there are test cases when you actually have different rows and column sizes.
Yeah, rectangular ones. 2 cross
Okay.
3 or 3 cross 2. Yeah.
Yeah, I think someone has asked me this question in a similar question in a interview actually. Someone actually tried to solve it without, they tried to do a circular rotation or something like that. I don't actually remember it.
Yeah, I got it what you're saying. Like corner elements will take 2 will be swapped with 18, but that's a different question. Like
No,
I
no,
got
not
it.
the square actually. Rectangle on in square you can actually. I try to understood it, but rectangle is the one they have asked me.
Doesn't look like in rectangle it will work because your structure is changed. If your columns become rows and rows become columns and the structure is changed, right? You need a different X
Matrix.
matrix to do that.
Okay, sure.
But there is a problem for circular rotation where we are just swapping the corner values, but that is also again a square matrix only, I think. I don't remember exactly. Okay, let's. Yeah. So there's a string given and we need to return a nested integer which contains your single string, and for this case you'll have what you say two will contain a nested list which will have two elements. The first will contain 1 2 3 and the next one will again be a nested list with a 4 5 6 value and 7 8 9 containing. Yeah. So any queries in this question or approach?
Yeah, so it is like a nested list
Yeah.
of numbers, and then the nestedness can be very deep also, right? You can have many nested strings
Box.
inside each other, right? Yeah.
Mm.
But then you actually do a parsing of the string, look for those square brackets,
Mm.
and if you find just a string inside it, just return that string with that nested integer, because it has
Yeah.
many of those, what you say, the
Square.
signatures for different functions, right? How to handle them.
Yeah. Mm.
Uh, but I don't think we use each every one of them. But if it is just a string, we can just pass into a constructor and return it.
Yeah.
Or else if it is not, then actually you can actually make another constructor and then pass on whatever is remaining, something like that. But you will have to use a recursive call. I'm not sure whether that can be done iteratively. It may be possible,
Stack and all.
but I didn't think of the stack. Yeah, stack might be possible, but I was just thinking if you can do a recursive way, look for the string. If it is a string, then you do a substring for that particular that string. You look for the comma, and then you pass into that same function signature what we have, and then add it to that nested integer. Something like that, yeah.
The first thing is the nested integer will have two members, right? One to keep the integer in example 1, and the other member will keep the list. So they have to be two members, or
I think.
right? There is nothing. I mean, to start with, either we will see example 1, or along with example 1 we can also see example 2, but no, actually they are mutually exclusive, either example 1 or example 2. So it is kind of a union of two distinct variables. One is an integer and the other is a list, and when it is a list, that is a recursive list.
List within list.
So I have not done it, but the idea that I'm thinking is basically we are simply passing through the list, right? Passing through the string. So if it starts with open bracket, what is that? Square bracket.
Box.
Yeah. Then we know that we'll have to use the list now. So that is where we will enter into the list state and start parsing the integer afterwards, because once the list starts, yeah, it has to be recursive actually. Once the list starts, the next one, instead of 1, it could be a open bracket again, open square bracket again. So it has to be recursive. That's all I can think right now. I have not done it, by the way, if anybody has done it.
I think it is recursive, that's correct. Yeah. So what you do is you look for a string if it is not in square brackets. If it is not in square brackets, then you just return that with that constructor, right? Pass it to the constructor using, you can just pass it to the constructor, or else you actually go and again recurse that. You know, at that time you can add that because it's going to be a list, as Rajendra was saying, right? Because you have that add function. But in that case, you'll have to again add that helper function or whatever you use it. Yeah, it is similar, but anyway, implementation might be slightly tricky in an interview. Yeah.
Do we need to check where the bracket ends?
In some cases, yes. Some of the implementations actually do check it very precisely. But I found in one, it was very, they check it though, but you don't have to actually look for a comma also in some cases, still it works. So it depends on how you implement it.
Like if we check for where the bracket begins, is that sufficient? Or do we still need to see where that ends, kind of?
So if you actually check for the start, then you have to check for the end also. And then you look for a comma. So you can actually separate the substring part with the least, you know, something like that. Or in one case, what I was working on found very easy to implement was like, you just look for both of them. If they are not, then you collect a string and then you actually create that substring of that particular string what you got, and then you use an add function to pass on the other parameters because you're shifting the index, right? So that will take care of the recursive nature of the function.
Want to share?
So considering the fact that a nested list contain only 2 elements, an integer and only 1 list, right? So if we just check the first character, whether the first character is a opening bracket, so that means it's a nested list.
Right.
That is a list, right?
Yeah.
And then the next character will start and read the character until you hit the either the closing bracket or a comma.
Correct. Yeah.
So up to that point, you will get the number. And then if there is a comma, so definitely there will be a nested list after that, right?
Yeah.
No, I think that's only for example 2.
But you still will have to implement if you're
so yeah, I mean, what do you mean by example 2?
Like that's not the general case. Like a list, like it says a list contains 2 elements, integer and a list. That's only for example 2.
A list may contain multiple lists, you are saying that?
Yes.
Yeah, it can contain whatever, I think.
No, it can, but a list cannot contain more 2 lists. It can contain only 1 list.
Yeah, but that list will have a nested list inside it. That is what I think Henny was saying, right?
Yeah,
Yeah.
that is fine because that is part of the another list at the second layer. But at that particular layer, that will contain only either only a number or a number and a list. And that list may contain any number of lists inside.
Right. That is
So
correct.
can we have one square bracket and then immediate another square bracket, or we'll have string here? Then only when
I think it is possible. So I think it is possible to have any number of square brackets consecutively, because that is list inside a list because that is nested. That is what we are calling as nested. So here is what the recursive structure looks like. So at one level, there will be one integer, only one integer, and a list, and the list is itself a recursive list. That is node recursive list contains one integer, possibly. I mean, that can be null also.
That
And
cannot be.
no, that can be null.
It can be null, yeah.
7, 8, 9
That's
is
what it comes to.
7, 8, 9 is a list without any integer there. So it can be null, and another list which can possibly be empty, for example 1. But if it is not empty, then it is the same node nested list.
No, Rajan, the 7, 8, 9 is a list, right? So that list contain only integer.
No. 7, 8, 9 is of type nested integer list.
No, for the parent of that list is, say, like the list which contain 4, 5, 6 as an integer and another list, right? And
Correct.
that list contain only integer, 7, 8, 9. It does not contain a nested list.
It is a nested list because look at the 1, 2, 3. The list content, its grandparent I am referring to.
Yes.
That's only one list. It is not containing any integer. So what I'm saying is, basically the node structure for us is, okay, sorry, is it?
you can share the screen if you want.
I have nothing to share right now.
Okay. Go ahead.
Yeah, so what I was saying is, Praveen, so 7, 8, 9 doesn't contain an integer, correct? But look at the...
No, that's not clear to me that why you are saying that 7, 8, 9 does not contain integer.
7, 8, 9. Okay. Now, you are right, actually. 7, 8, 9 is only containing the integer, and the list part is null.
Yes, that's true.
And just its parent has got both integer as well as the nested list. But its parent, which is 1, 2, 3, it contains integer and a list. And think about its parent, because it is a recursive structure. It is just the list, no integer.
No, so that is the list. So we are now inside the list, right? When we are inside the list, so what that list can contain?
No. What I'm saying is, think out of the list is also contained somewhere, right? Because it is a recursive structure. The nodes should be uniform. But when we are saying that 1, 2, 3 is a number and its sibling is a list which starts with 4, 5, 6, we have already got that uniform node structure, that this recursive list, this thing can, okay, probably it will be better if I...
Yeah, this is our input, Rajendra. So we don't care about, forget about the node, right? So think about that is the input we will get, right? And that input, when we will pass this to our recursive function, so we'll check that whether we have to treat that as a list or as a plain integer, right? So the first character will tell us that whether we have to treat that as a list or as a integer. So first character is not an opening bracket, so that means a flat integer. So the node which I'll create for this, I will create a node as an integer and said that, oh, this is an integer node only.
I think we are talking two different things. So what Rajendra is explaining if he does not know the solution, what it looks like. And I think what you are referring is like how we'll drive to the solution. That's like my assumption here. But yes, I agree with you, Praveen, that if I have to look into solution, how I'll know whether that is just a value or a list, the bracket will tell me. But I think what Rajendra was telling was how this actual structure, if I have to map into my my mind, how that structure will look like.
Yeah, that's I was trying to explain, and I'm thinking in the same way, even though I don't have the solution for that.
Mm-hmm.
Yeah,
No,
so this is how I'm thinking that how I will actually take the input and drive it from there.
But
yeah, no solution. I just know the input, how my output will look like. I think there what Rajendra was telling.
Okay.
what I was saying was, if we establish a recursive structure, our code will naturally form shape around that. What I meant by that is, so let me think a little bit.
Yeah, so I was saying that if as soon as I see a opening bracket, so I will recursively call the function again with my and shorten the new input, the smaller input.
Correct.
Yeah.
Or else if you don't see that square bracket at the beginning, you will just convert
That is the
into a
end.
string.
Yeah.
That might be a base case for a recursion. I think he's also talking similar.
Yes.
Yeah. Maybe actually let him explain it the way he wants to say.
Okay.
Let's
see. Yeah. No. I agree. That is what I was also thinking. So basically, the square bracket opens. That basically, we should go to the next step of invocation, where it will contain a integer as well as a list. So this is the next level, and when it returns, we have got those things put in a list.
So for I think first place 1, 2, 3, and the other thing, they are two different things. That are two different nested integer objects. Or
one nested integer object, right?
So 1, 2, 3 is one nested integer object, and then another starting object from bracket, which starts from 4, 5, 6. That is another nested integer object. Then again, it will have more nested integer objects.
I guess my question is it possible to have, in the second example, 1, 2, 3, comma, say 1, 2, 3, comma, 0, comma, then bracket starts. Is it possible?
1, 2, 3, comma, 0.
And
comma, opening bracket.
What is that 0 you are thinking?
I am basically thinking that in the list, it can contain arbitrary number of integers followed by, I mean, not followed by, and any of the position can be another list.
No, I don't think so. Or probably let me try to explain on whiteboard.
Sure.
So please let me know when you can see the whiteboard.
Yeah.
I might be wrong, and you might be guys already knew it, but let's see, because this looks little confusing to me also. Could be good if we just clarify. Okay, so what I understood, the output should be a nested list. This is one object. And this would have a list of nested list. So this is a starting point. This is again list of nested list, right? Oh, sorry, this is nested integer. So this should have list of nested integer, correct?
Yes. That is example 2. Okay.
Yes, and then I'm returning this object, and followed by this list would have one more nested integer, which will have value 1, 2, 3. For this guy, there won't be any list. The list would be null. And then it would have another nested integer where there won't be any value, but there would be another list of nested integer, which would have another nested integer, which would be 4, 5, 6. And then this would have another nested integer where there won't be any value. And here also the list would be null. My writing is so bad, sorry for that. And there would not be any value here. And then there would be another list of nested integer. Where we'll have another nested integer, which would be 7, 8, 9. And here the list would be null. So this list would be null. So that was my, if I agree with this, fine, please let me know if something I'm assuming wrong here.
So if you nested integer, once you wrote, it contains a list of nested integer. And then,
if you see the structure, let me also put this, sorry. I will remove some things. Yeah, so basically, let me remove few things from here so I can show you the entire thing. Okay, so this is, I think, is a structure. So it says either it is an integer, if it is okay, so if this is an integer, then it cannot have another list like this. So it was having 1, 2, 3, it could not have another list inside that. If there is no integer, then it will have another list like this, which will have another nested integer, which will have 4, 5, 6, but then it could not have any other list, this one. So this list object would be null there. Are you guys with me?
Yeah, Sim, I think
Yep.
this clarifies a lot of things.
Yeah, so that's what I think is what I was trying to say. Either it could have an integer or it would not have integer. If it does not have integer, it might have a list, it might not have a list. If it has integer, it will be signified here, like is integer true. Then you can even say get integer. But if it does not have integer, then it would have a list like this. That's what is my, and this is a top level nested integer, which will have a list of nested integer. One will be 1, 2, 3, and one will be like this one. Sorry.
How are we going to pass the string to the recursive call? Are we going to like if we're going to give a copy of that part after coming back? How would we know that which part of the string should be handled in that recursive call?
Yeah, so now, okay, so if this is clear, if we all like, if we have agreement on this, now we can look for solution. So looks like even I haven't solved, but for me, I've solved a separate problem where the nested integer was used. So there I have researched a lot. But here it looks like we have to split in some way, like Praveen was telling. If this does not have a bracket, then that means this would have a nest integer with the with the integer one like this. Otherwise, it would go into this flow. Again, when you don't see a starting bracket, then it will go this flow. If you see a starting bracket, it will go this flow.
Yeah, that's right.
I disagree with your problem statement because the way I read the problem is a list contains many elements, right? So let's say the list contains 4 elements. Then according to the statement, it says each element is either an integer or a list.
Yes, so that's what
So that means 3 of those elements can be integers and maybe 1 of them a list, or 2 of them integer, 2 of them list. And you don't know the position where the integer or where the list is gonna be.
agree. But if you see the least common denominator would be integer, like in 7, 8, 9 would be integer at the end. Does that answer that? So what I'm trying to say is, as soon as you're seeing a bracket, that means that could not be a nested integer with the value. It would be a list only. We have to go again, divide it, again split it, and keep on going in different directions.
Yes, as soon as you see a bracket, you know it's going to be a list containing at least 1 element.
Yeah, it will at least, and at that time I don't know whether that would be an integer or another list.
Right.
So now we have to do some more magic here to find out when I see a starting bracket, it basically does it is another list. Would it have more lists inside that, or it will just integer and I'm done? In this case, when it started with the bracket, it was only having 7, 8, 9 here. Then I was almost done here with 7, 8, 9.
Yeah, I think that can be your base case.
Yes. And then, like coming to what Rajendra was telling, it has to be recursive in nature, or it can be iterative also.
Yeah, I think we all agree it has to be recursive. The question is, what exactly do we recurse on? Do we recurse on the element that's right after, starting right after the bracket?
Or
I think it's on the comma, right? I mean, we have 3 conditions.
Comma. After the comma, we recurse on the rest.
Yeah, and whenever I think we have open braces, we will create a nested integer. I think so.
But the rest is gonna be 1 more closing bracket.
Closing bracket is I think that's a case where we return back, I think.
Not necessarily, because might be. Yeah, you can check those. There are many test cases to be.
Yeah.
If someone has solution, he or she can share. And
well, I can share you a very easier one. What I did.
Okay, easier.
Before Shashank takes the very complex one.
Okay.
I'll just share the quick thing.
I'll stop sharing.
So complex here is like more optimized in.
Yeah.
Okay.
So because he does the most optimized one.
Okay.
So before he shows you that, I'll just quickly show you mine.
Sure.
So I'm just using this one. This is my entry function point. This is size, and I'm just returning a if it's null. And then there's the helper function. I'm using an index actually to follow the string. So here in this helper function, I start with a nested integer here. Okay. And then I'm just doing a parsing. I'm just parsing on if the string value is a character. I'm just taking that as a token. Right, and then creating another nested integer object inside it here. Okay, and then I'm adding to this one the rest of the objects, and then I'm calling this helper function again. Okay, and then this keeps on recursively going and then returns from here. Okay, so if the first case, if it's the first case, it won't enter the for loop at all. So it will just return from, yeah, it will enter the for loop. Yeah, but it won't go in the else condition, but it will return from here. So, but actually in some implementations, I've seen that they actually specifically look for the comma. So that is a slightly,
you're not looking for comma.
yeah, it actually works without a comma also.
So you're saying when it is not a start, not the end, then just add that to that guy. Okay. If it is a start, and then what you're doing, you keep on.
So what happens when
Because the index actually moves ahead right here.
Okay.
And therefore you look for the next one in this helper function again, because then you come again inside this one, the recursive, and then this is the least, right? What you are adding. So because you just treat it, whatever is for the first token, okay, and then you actually pass it to a constructor, you create an object, and then you are looking for the least, that what you are mentioning, right? I think.
Okay.
So that least actually is from here, from the next index. So again, it will go in the helper function. So for the comma, actually, they look for the specific index of that comma, and then they move one index ahead and then take that string, or take that least actually. Because whenever you want to go in the helper function to look for that, you have to be on that open, the square bracket, right, to assume that it is the least.
If it's not a comma, would it append comma to, I mean, if it is a comma, would it append comma to line 39?
If it is not comma,
No, if it is a comma, then it would append comma to line 39, right?
yeah, so it looks like, but I don't think so it does. We can take a test case. Okay, I'll write it here. I don't think I should take this comma here, right?
Yeah.
But that doesn't look right to me. Oh.
Are you converting the character to integer somewhere?
Oh yeah, there's something wrong with the solution. Sorry.
Are you at line 35? Your int is token, but
Yeah. I think that's not the correct one. Sorry.
I think you can
Yeah, it can treat comma as a number, then return different value.
Yeah, maybe I'll just look the other one.
Look for your submission.
Yeah. Oh, I look for the submission one. I'm sorry.
Oh, that's fine.
Yeah.
No, not this one. It's a different problem.
Oh, it's a tree.
Parser, I think third tab, Santosh. Yeah, submissions. This one.
Is this one? Yeah, that's the one. Yeah, This one has the comma. Actually, I look for the comma specific, and actually didn't want to go in this because it's very too much of implementation details. But what here it does, but I have to go here. Okay, so this is a DC rare one. So as Praveen was saying, you look for this one, and then if it is actually not, then you say it is just a string. Okay.
That means the first string you are hitting.
Right, the first example.
Yeah.
Or you come here, okay, and then when you come here, you look for this open and close. Okay, you just all do all these counts, and here actually what Leon was saying about the comma. You look for the comma, and also look for if this is 0, and then you create a substring, and then you pass that into this one. Okay, and then you deserialize that again, and this will be raised. And every time actually you increment the end value when you actually establish one string. And you are adding here. Okay, so one by one you are adding.
And at last, I think you're checking.
So the last is for the end case one. One more case if you are left with something more, right?
Yeah. Then you take a substring from end to end.
So in this actually, the way you look at this is actually just looking for one string, correct? So what about the other? If you have this one, because first it actually pairs and actually taking 1, 2, 3, correct? And it's just passing that into the deserialized one, and then it is adding. So, but what about the other guys? So again, it will go in this loop, right?
And then check the count value if it's not.
So again, it will go inside this loop, and again, it will create one more. Okay, so then it will come to 4, 5, 6. Then again, it will add to that. Correct.
Yeah. I mean, many like conditions are there, like comma again, then 0. So
but
count equal to
I don't think so. It is doing any nested conversion here, right?
Yeah.
That's happier to me. So therefore, I was actually so much hesitant to go this route. But yeah. So do you see anything which is nested over here, but it still is working? Right, because you have to see something actually pass on, then you can see if it is you are actually putting the whole thing inside. So it can go in that recursive way and actually split those, right?
Yeah, makes sense.
Yeah, the other way I can see it is like we have a stack of nested integer. So at the end, the deepest or the most nested will be on top of the stack, right? So we can at the end when we can pop it out and build the integer list, the nested integer.
Oh, so you have a stack-based solution?
No, yeah, I'm thinking, look at your solution. I'm thinking, maybe instead of do recursive call so that we can have a stack. So 1, 2, 3 would be, the bottom of the on the stack, and 4, 5, 6 will be on top of it, right? And then we have 7, 9, 8. So, I was thinking we don't need to we can avoid recursive call by that.
You mean to say we can just avoid this recursive call by using a stack, right?
Yeah, we build a stack of nested integer.
So recursion is also using
stack. No, but I'm trying to explain you, like I didn't understand the concept when we are talking about this is going inside a nested one, right? So I was under the impression, like when you are passing inside this deserialized one, you should pass this guy whole of it, right? So it gets broken inside, and again it forms a nested list. nested in nested list, because it is a nested, right? So, but here if you look, it is just parsing the first 1, 2, 3, correct? And then it is adding to this, okay? So the ANS is nothing but a nested integer over here. But when it goes into the recursive call, it is just passing the token of 1, 2, 3, and it returns from here, okay? So here it is doing nothing but converting to string to integer, and then it is adding in the list. So next time it comes here, okay, in the same iteration, and it looks for 4, 5, 6, okay? So when it looks for 4, 5, 6, it finds that substring, and again it ports here. So this time again it returns just a string, okay? It returns a string with a nested integer object, and then again it adds in. So here it is actually completely removing each and every one. So what happens if you have many nested calls? So
I think that is correct. So first you have 1, 2, 3 in your nested integer, and then you went with another nested integer which starts from bracket, and then you again went inside that.
okay, so it just has to remove each and everything and then flatten the whole stuff, right? And just return it.
Let's start with the 1, 2, 3. So initially you have a starting bracket. Then your count increased. Then you never got a closing bracket.
Yeah.
Then when you got a comma, that time count was 1.
Count was 1, yeah. Okay.
Then you never came to 44. Then you almost...
He took the substring that 1, 2, 3 he took, and then up.
No, but the count was not 0.
Count was also.
When the count became 0.
So count will become 0 at this position.
When it is the 7, 8, 9's first closing bracket, I think.
At the end, right?
But you started with 1. You never started with 0. That line 40, I is 1. You never started with...
Oh, yeah. So it is actually removing this.
Every time it is a nested integer.
So yeah, first time it is going to 123 because we are not actually even entering here, right?
Count. Yeah.
So you will have just 123 here.
You will have 123 when you see a comma.
Yeah. And the count will be 0 here in this case. So first actually it will come to 123, yeah.
But that time you never have seen the starting and closing brackets.
Yeah,
so that became one nested integer for you. And you put that into your answer.add. When you do answer.add, it added a new nested integer. No,
actually it's a list vector actually, right? Yeah.
Basically, when you went into deserialized string, it went into your base condition somewhere.
So it will go here, right? When you deserialize here, it comes here, and then it doesn't find that, then it will return this one.
Yeah, so that became first nested integer 1, 2, 3.
Yeah.
Then it followed after comma, and then it did a starting bracket. The count became 1.
So when I come here, actually it will be 0.
First.
And then you never see a comma.
Okay, so in that case, actually, it is actually when you come to 0, then you are actually taking this stuff, okay, and then passing it to the deserialized one, and then again it is repeating the whole stuff. Yeah.
No, wait, we haven't seen a comma.
And
so
what it is returning from this function? Can you please scroll down a little?
It is nested integer ANS.
Can you scroll down? No, basically after you sent 1, 2, 3, then another bracket start. The count became 1.
Right.
Yeah, so it will stop when he sees the second close bracket.
After 7, 8, 9, then bracket, another bracket.
Yeah. Second last from back.
Yeah, then the count will become 0.
0.
But what will happen that time?
So then
entire
it is going to have such this one string, right? At that time, 4, 5, 6, 7, 8, 9. So that whole stuff will be passed on to this guy.
How it will
Yeah.
go to line 47 when there is no comma?
No, I think 4, 5, 6 will be passed first. Then
How 4, 5, 6 will be passed?
Looks like it is passing 1, 2,
Yeah,
3
so
first.
for the last one, when it is not a comma, this condition is going to be there executed.
Okay, so let's see what is happening here. You are doing a substring of anged to n my so anged is, oh, you never changed anged after that.
Here the end is changed.
Oh yeah, after we saw 1, 2, 3, the anged got never changed.
yeah, because it never entered the if else if loop.
Yes. And now you are taking from now, okay, now it makes sense. Now at line 54, you are taking from first bracket, which is before 4, 5, 6, till the
Second last.
yeah, n minus n minus 1. Okay. And now the process will start.
Yeah.
Oh my God.
Yeah, it's like very precise. Like, I mean, decoding it is bit like intricate.
So the input won't contain a list first and the number next to that?
Pardon?
Sorry?
Will the list, if suppose first in the second example, we got the list of 4, 5, 6 and the list of 7, 8, 9. After that, we got a number 1, 2, 3. Is that a valid input?
Okay, let me do it here. What you are saying here, because there are many test cases.
We get a nested
Initially
list, then
we
we get a
got
number.
initially only 1, 2, 3.
After 7 and then you want to put something else?
No. No. After first we need to have a nested list. Then we need to have a 1, 2, 3. After the nested list.
Where you want me to put something?
And in the first bracket itself, but after the nested list.
Oh,
We need to remove 1, 2, 3, comma.
After 1, 2, 3, comma, you want to put something else?
Remove that 1, 2, 3, comma.
Like this?
Go to the end of the list. One step back.
Okay.
One step, comma 1, 2, 3.
Here, comma 1, 2, 3.
Yeah.
It's not a valid one, I think.
But they never mentioned that we will get a number first, then we'll get a nested.
It looks valid, yeah. So even you can have some test case, this very simple basic test case like, 1, 2, 3, like this also you can have, correct? So this also should work, correct?
Hope so.
Yeah, sure.
Yeah,
No, it doesn't work. So, but you just have to have a single integer and then you can have all these stuff.
Yeah, they
So
are
either you have it before or back, that doesn't make any sense. Okay, oh yeah, I think this should work, right?
should work. There are 3 nested integers.
Yeah,
You never go to that line for which you are
this
showing.
also works, yeah.
So the line which you are showing earlier, yes, this one.
Yeah, so when here in this case, once you execute this 1, 2, 3, so and once you hit a comma, right? So the other stuff inside it will always be executed by line 52 and 58, and then from there again it will come here, and it will take just the first string, the first integer, and whatever is remaining again it will push in that, but at the time again it will be executed by 52 to this line, and then it keeps on doing it. So here actually in this for loop, it is going to only extract a single integer every time. So the processing of the nested will actually be done at the very end. Yeah.
That is a
Yeah. So actually now I got to know about it when Asim was explaining it. Yeah. because I thought this would work and I was working on this, but it didn't work. So I looked at the solution and then saw this is one more thing I need to add, and then it worked.
But can this be avoided using without doing from line 52?
He has to take another some empty string and then do some.
So if you want to avoid that, then what we can do is remove this count equal to 0 and then pass the whole string value, right? Something like that. Maybe, or even don't look for the comma, but when we hit on a comma, we just increase that integer value. So we means cross the comma and then we just pick the whole string, right? And then it passed to the deserialize1 again. So it keeps on removing the first token, first or last token, wherever you find a string. Yeah, but now I think Dilip was saying, right, if we have something behind it, then how do we take care of it?
Mm-hmm.
But is there a very simple way someone has implemented? Because I think it's slightly tricky to understand this.
I was going through one discussion.
Yep.
I'll show you.
Please, yeah.
I'm not sure. Let's see. We'll try. So this is the solution that I'm going through. So it's like when you hit the first one itself as an open bracket, we'll start from, leave that open bracket and then recurse from there on, like 1 to the end. So this is the recurse function. It's like instantiating this one. What we are doing here, like I've created empty string is created first, and loop is running from one like till the end of the array, and just checking if that character, whichever you have picked, if it is a digit or they mentioned this sign, just we are appending that to the empty string whatever we have made. Okay, and coming to the closing condition, it's like whenever you hit a comma or what do you say, close box bracket, and if num exists, like if it is not empty, then just you, there is a function, eval function they have given, in that you pass and just add it to the nested integer, and again reinitialize your what you say num2, like for the next section after 123, that 4 5 6 and 8 9, for that again you reinitialize your num to empty space empty string. And again what do you say, if you hit this, like 2 3 box brackets are there at the end, if you hit the first one, just you return this nested integer and then increase the index by 1, else again recurse it the way, like from I plus 1 to the rest. So
Santosh, can you put your solution in the chat somewhere?
Okay, I'll do that. Yeah, can you walk through very slowly? Actually, I think that
will be better.
I think that is very good way of doing. I think because we are using all the functions, right? What we are explaining in that interface.
I think let's walk it through this.
Yeah.
So
Well, I'm just sharing in the chat now. I'll put in the Slack also later.
So first time you saw the bracket right here. So we'll start recursing from 1 to 3. We'll have to see the solution. So what they are doing is, like first time you have seen, I'll start recursing from leaving that one. Okay. And now next is your, I've created this empty string, and if it is a digit, I'll append it to C. So what I'll do here, where is that? What I'll do, I'll create a num, and as long as I see the digit, I'll just append all this. So your digit will be 123, right? I mean every character is a digit. So and rest what they are doing, Now next you are hitting this comma, and if number is existing, just you append it to your result. So one nested integer will be your 123, right? And next again you'll hit this condition got satisfied, like you hit this, so you did it. Now it won't enter this. Now again next time you will see a, what do you say, next open bracket, then you recurse on from there to, what do you say,
So the next one. So you're actually
next one from here again you will
uh-huh.
again you will start appending 4 5 6 to your num. Okay, and again you are hitting a comma, and when once you hit a comma, what will happen, you'll again append it to your nested. The moment you hit a comma here, you'll again append it to the
Yeah, the
whatever nested list or whatever it is. So to that, like 123 you will hit, sorry, I mean in the result set you will hit 4 5 6, and the again you will make it to empty set. This will be empty, and again if you start from here, so see, as long as you see the digit, just append it to the num, and the moment you hit this first close, so when you hit the, so either comma or first close, you just appended this, so you'll append 7 8 9 again, and what is saying, sorry,
Yeah, you put 7 8 9, and then actually you are actually going to hit on C equals close box bracket, right?
oh, yeah, that it's there,
Yeah.
like yeah.
So when you hit that, you return that along with I plus 1.
Plus 1 next to the next one, like it will pass.
So if you have another string, another list, then it is actually going to take care of it, right? So that works.
Yeah.
Okay.
So every time you hit, just you reinitialize this num and just take the digits in it, and the moment you hit the comma, you just append it to your, what you say,
Yeah, the result one. Nested.
whatever result, and again keep, if so on, if you keep hitting, just add one this, and then just go for the next, like next iteration, like.
This looks straightforward, actually.
Yeah, it is bit straightforward compared to the like one that was with.
Yeah.
But lot many conditions are there in this. I mean, it's coming up with this is again not a trivial task. Or we can write. I mean, because it's a straightforward only. The moment you see comma and this, that's like you can bound your solution at that point.
Yeah.
And then
that makes more sense. But why are you looking for negative? Is it we have negative numbers? If we have negative numbers,
no, we have this some sign is there. Like I'll show you here. This one, this it can come.
So that it means it's a negative number also, right?
Oh, it's a negative only. I thought underscore something like that.
No, it's a negative number. So you can have digits and these all extra characters.
Okay. Yeah.
Okay.
Yeah. So any queries? Or
And your base, if you go to the function entry point, just go below. Can you scroll down? Yeah. So here, actually, you are actually on s equals 0, opening of that one, open bracket. You look for if it is open bracket, then you go for this nested recursive function, or else you return with the just a string value.
Exact.
Okay.
That integer itself. It will go into eval and take integer is a function there.
Yeah. I think this looks very straightforward implementation, right? Yeah.
Yeah, we can proceed to next one. So this is like next is like insufficient nodes from root to leaf paths. Even the root of a binary tree consider all root to leaf paths from root to any leaf, and a node is insufficient if every such root to leaf path intersecting this node has sum strictly less than the limit, and just delete all the insufficient nodes simultaneously and return the root of resulting binary tree. So if you see here, this path 1 to minus 19, this path, your limit is 1 and you'll have a value of this path less than 1, that is 0 and negative it will go. So we are just removing this area. And similarly, you can see in this, and again 1, 3, 4, 7, and again minus 19. And so again, it will bring you to the negative. So we are removing that, and 1, 3, 7, 14 is the required path, like where you don't have any, it's not less than the limit, and same goes for the left part. Yeah. Again, if you see 5, 4, 9, 11, 20, 21. So why they have removed here? 11, 1, 12. 12, 4, 16, 5, 21. 21 is less than 22, right?
Yeah.
Then why have they? Oh, huh. If it is less, we have to remove, right?
We have to remove, right?
Yeah. I thought the other way.
Sorry, could you
Yeah. So,
sorry,
pardon?
I missed it. Sorry, I was not paying attention.
Yeah, yes. Sure. It's like limit is given to you, okay? Like your limit is 22, whichever path you find when you sum them. Like if you sum this path 5, 4, 9, 11, 9, 20 plus 21, which is less than your limit, then you need to remove that particular node which is creating a, like, what is it, nonsense here, which is making your limit less than this. So we are removing this particular node.
So only one will be removed, or?
Yeah, in this area only one will be removed, because other, if you go through this 5, 4, 9, 11, 20, and this is 27, which is greater than 22. So we are keeping this path and just we are removing this one. And if you go to this area, 5, 8, 13, 17 is 30, which is greater than 22. So it's good. And 13, 17, 22. I think this equality is also allowed. But if you go to this 5, 8, 13, 4, 17, 3, 20, it is less than your, what do you say, 22. So again, it's removed. I mean, you can't remove this entire because others are attached to it. So just node you have to delete it.
So always we are only removing the leaf node if the condition doesn't satisfy.
It depends.
No, I think the entire path will be removed. Yeah, but here you can't remove no, because others are satisfying it. So you have to keep this path.
Oh, I see.
Because here you see, if you go here, this entire path is removed. Limit they are setting as 1. So you can remove only this path because the other paths are satisfying. You have to keep that one.
Okay.
If like it was directly 1 to 99 and it was nothing here, then I think this left part would have been discarded completely.
Okay.
So you actually go through a path from the root to any of the leaves and you keep on adding it, right? So whenever you find if it is greater than the limit, you don't do anything. But if you are at the leaf and you find it is lesser than the limit, then you start removing that node, right?
Yeah.
Okay. And then you do it, keep on looking for all the paths in this whole tree. And if they are not satisfying the limit condition, then you remove them, or else you just return the whole tree, whatever is remaining.
Yeah, exactly.
So at the end, all the paths should have a sum
value,
greater than the limit, greater or equal to the limit. Yeah.
Limit. Yeah, equality is also there.
So this looks a recursive implementation. Yeah, it can be done iterative also. I think sure, right? It would be possible to implement it iteratively. And actually, we are able to do that once, maybe you can use a in order
Stack.
traversal for that, right? Yeah, stack, using stack. Then that should be possible. I think so. I don't want to comment on that. Okay.
No,
But
no.
the recursive should be anything. We can just look for something, when we are at the leaf, and if we compare what is the sum till this point, when we are at leaf, and if we are satisfying it, we're fine.
Otherwise,
Otherwise, you try to delete it. Something like that, yeah.
that should work.
But then I don't know how to go ahead when you delete some, because you said, right, on the example one, if we have 3 minus 99 nodes, so you remove one node because you are at the leaf, right?
Leaf.
But then how do you remove the one which is its parent? Also, you cannot remove that because, sorry, go ahead.
I think we can do it a little simpler. So because it is being trimmed from leaf to upwards, and in a tree traversal, always the traversal happens from root downwards. So it looks like the trimming is happening. So it would be a post-order traversal. So basically, recursively, the things will happen first. Then we'll take decision about our current node. What I mean by that is, I'm looking at example 1. And in the rightmost one, 1, 3, 7, minus 99 will get trimmed. But 1, 3, 7, 14 will remain as it is. So in that case, so what is happening is, think about the root, the node minus 99. We know that that node should go. I mean, that node itself knows it should go. So it will return null to its parent. So its parent is 7. 7 has already, it is in post-processing mode. It has already called the function for minus 99 as well as 14. And it has got the results. Minus 99 is saying, okay, I am returning a null. Sorry. Okay. Yeah. Okay.
So Rajendra, you're telling that from 3, when we go to minus 99, so it's already lesser than our limit. So stop there. We should stop.
No. I'm following example 1. So 1, 3, 7 minus 99, and its sibling is 14. I'm talking about that one right now. What I'm saying is, it will be a post-order traversal. So think about the node 7. The post-order traversal means it has called the function recursively on its two children. One is minus 99, the other is 14. Minus 99 doesn't have anything to call down. So it basically does its own non-recursive action, which is, if at my level I am less than limit, then I am returning null. I am killing myself. Okay, like that, minus 99 return null, but 14 is saying I'm all good. I am all good. So what happens is, 7 says, okay, I have one guy which is null, the other guy is intact. I should not kill myself. So what it does is, it says, okay, my left node is null, but my right is 14, and I am staying as it is. Now let us take our attention to the 1, 2, minus 99, and both of its children are minus 99. At this point, the leaf minus 99s, they are saying, okay, we cannot satisfy the condition, we are killing ourselves, we are returning null.
So which one, the first minus 99, right?
The leftmost minus 99 on the leaf level, 1,
okay.
2, 4, and as well as the right one also, because we are counting from top to bottom, right?
Okay,
so
yeah.
basically, both of them are basically returning null. Now the one label, the sibling to the 4, that minus 99, if you could hover, Sasan, could you please hover your mouse over the minus 99 over there?
Oh, the parent of those two minus 99.
Yeah. he says, oh, both my children are getting killed. There is no point me staying here. It also returns mine null up. But at the 2, it says, wait a minute, my right is saying it is killing itself. It is becoming null. My left is still okay. I should not kill myself. So it returns, it accepts the rightmost child's null value, and it returns its own pointer upwards. So it is a simple post-order reconstruction problem. It is a very simple problem.
So you are saying if both of them return null,
so
then you want to kill that node, correct?
Exactly. It will kill, that means it is returning null.
Yeah. So but what happens if we are at the like 1, 2, 4, 8? At 8 also, you are going to return both of them null.
No, the 8 is a leaf node. It has nothing to call to. Okay. The leaf node is not looking. Leaf node knows that it is a leaf node. It basically says, okay, let me make my own judgment. So judgment is basically if the sum that I have accumulated till now, including myself, if it is greater than equals to limit or not. If it is satisfied, I am staying. Otherwise, I am returning null. You're getting what I'm saying? How can I say?
Could you please talk about that, the 290 minus 99 minus 99?
Sorry, what was the question?
You talk about, explain that part again, taking the example 2 minus 99 minus.
So I'm just saying that it is a post-order traversal happening first. So 1 calls 2 and 3 as well, but let's come down to 2. 2 calls 4 as well as minus 99. Let us focus on minus 99. Minus 99 is calling the left 99 as well as the right 99. Both of them are leaf nodes. The leaf nodes basically make the decision on their own. They say, okay, we have nobody coming out from us, so we will make our own decision. So at minus 99, it is clear that the accumulated sum is way less than the limit. So it says, okay, I didn't satisfy the condition, I am returning null.
So wait a minute. So when we reach the leaf node, so we check that it's not satisfying the condition, right? But it could be possible that the condition is not satisfying because some node on the path is actually creating that problem.
But I don't have, do you have an example like that? Because we cannot simply optimize it from the intermediate node, because we'll have to see the complete path until leaf. What if the leaf has a sufficient big number to compensate that? Because it is a path to leaf.
You can have a positive number big on the leaf, yeah.
Yes. So we cannot simply shortcut there. We'll have to come to the leaf.
Okay.
If sum of the from root to leaf is not satisfying, then only we are removing that path. So we have to go to leaf.
So what I'm saying is the same approach, just a little bit tweak, depending on the details of the question that is being asked.
Yeah, but that is correct. What you are explaining, is might exactly work. There's not an issue. Only thing what I didn't understand when you say when you are at the leaf and you satisfy the condition, so you want to delete it. That is fine. But and then you are again saying when you are recursing very down, but in case when you return both its left and right children's as a null, then you delete that node also. Yeah, I understand it goes for minus 99, but is not the same condition satisfies for any leaf? So how do you differentiate between those two conditions? That was my question actually. So yeah, there is some trick to that though.
No, it is clear, right? The one who
I'm thinking the example here, let's say limit for this example, limit is say like minus 100, right?
Okay.
And that node after 2 is say like minus 110.
Okay.
and then when we'll go with that path, so the child will say that, okay, I cannot satisfy, right? But if we remove the parent under minus 110, it could be that may satisfy, right?
We are removing when we go from bottom to top.
So
First we go to the leaf, and then when we go back up, then we check if we need to remove it or not.
So if that is that looks like a new different problem than what I am solving. My understanding was it is always the path till the leaf. So what Praveen, you are saying probably is a different problem.
Yeah, I mean, that's why I'm not able to understand. My interpretation for this problem was that as soon as we find that node can exist anywhere on that path.
As soon as not, I think once we go to leaf, and if that path is not satisfying that condition, then we start removing it.
Yeah, so we remove the nodes which don't satisfy.
After coming to leaf, then we return back and then we start removing.
It does not say that you have to remove from the leaf. Where it does it?
If it doesn't satisfy till leaf, then we start removing that path. If you can go in the description,
Delete
I think that
insufficient nodes simultaneously and return the root.
Yeah,
I mean, problem statement, it's not clear to me.
Okay, so if see, when we go to the path, we find it's not a satisfying condition. So you remove the leaf, right? What Rajendra was saying is that's correct. You know, when you remove one leaf, left child of a node, okay, you go and check for the right child of the parent or its sibling, right? If it is also null, you come back. So now your root actually of those two leaves which are deleted becomes a node which also doesn't satisfy the limit condition. So you want to remove that also.
Remove that, yeah.
Right.
When we are reversing back from bottom to top, then we are checking both the condition left and right, and then we are removing that.
No, what he explained that, I mean, that is correct. So I'm talking about the problem. So my understanding for this problem is that, so the example what I just gave. So here in that case, I'm thinking the expectation is that we should remove the node minus 110.
No, I think we should
because
remove the paths of the sum. The sum, before we get lesser than the limit, we need to remove the nodes in such a way that at the end, all the paths should satisfy, they should remain above the limit or equal to limit.
Actually,
so whatever the way you remove. But
I mean, if that's that is the requirement, that to remove from the bottom, from the leaf, yeah. But I think that's why, I mean, there's a 321 down for this problem. It's not clear.
Praveen, I think the definition that we have in the middle here, a node is insufficient if every such root to leaf path intersecting, I mean, going through this node has some strictly less than limit. That is the recursive definition we have there. So
yes,
if every root to leaf path going through this node has some less than the limit, then this node itself is also insufficient. So it should also go. So what it tells me is that if both my children are killing themselves because they are insufficient, I must also go, because the paths, every path that went through me are now insufficient. So I must also go. That's why if both left and right are going, becoming null, then I am also returning null. If any of them are staying back, then I'll stay back.
We can again do that minus 110. You are saying first root minus 99 minus 110, right?
Yeah, minus 110. Yeah, first after 2 it's minus 99 instead of minus 99. It's, let's say minus 110.
So when we are coming from 1 to minus 10, we don't check to delete this node at that point unless we go, because we might have something down here 110. Then that doesn't satisfy that condition to delete. Unless we come till leaf, we don't know that if that path needs to be deleted or not. Right?
Yeah.
Makes sense.
I think, Praveen, why there was a down for this vote for this solution, because of the same thing. Earlier, there was a lot of confusion. They actually have changed the problem statement now. And therefore, they're specifically saying you make this strictly limited. Yeah, what Rajendra was explaining. And therefore, now it is okay.
Yeah, because
Yeah.
now it's a good problem, right?
I don't know.
I mean,
Yeah, but Rajendra has a solution, right? So yeah, he was explaining it.
yeah, it will
Yeah, I mean,
recursion will get revised.
if we say that we have to remove from the leaf, then that is okay. But still, somehow it's not clear to me
I
what is the
tried.
expectation here.
Right. Yeah, it's very tricky to understand that problem, and therefore I was asking him how you differentiate between those two leaf conditions. So he was trying to explain. Yeah, and that was something very interesting.
I tried returning Boolean like true and false if that satisfies the condition, and that makes it little easier to understand. I can share if.
Yeah.
Sure.
Yes, please.
Go ahead.
So here I start with each node is returning true or false if it is valid or not. So I go till the leaf node. When we see that this is leaf node, if sum satisfies the condition, I return true, otherwise I return false. So for each leaf node, we are returning that. So from the leaf node, if I go one level up, I'm checking both the nodes, first left and right, both I'm considering it's false. But if root dot left is not null, then again I'm checking for that left child with whatever value we have. If this left child is returned false, then that means we have to change the root dot left to null.
Oh, okay.
And we have the left value, which is Boolean, true or false. Same thing I'm doing for the right. If the right is Boolean is false, I'm setting it to null, otherwise I'm recursing again.
So along with the going to the left, you are adding also, right? From root, you keep on adding one plus.
Yeah. So if I have the result from both left and right, if both of them are, one of them is true, then I have to keep that node. I don't have to delete because one of them is root true, so that will carry that path. But other one, which was not satisfying the condition, that I'm setting here only to null.
Oh, okay. Yeah, so if you write it explicitly, it makes more sense now. Yeah.
So this was easy to, initially it was difficult, but once I started with the Boolean value and
I mean, the solution is simple, what you explained that, but still the problem, reading the problem is not, I mean, to me, it's not clear like that is expected. I was interpreting in a different way that we have to remove that node from that path so that the path now satisfies the condition. Sorry?
Yeah.
As soon as initial thought was, even I got confused initially. As soon as I see that it is not satisfying, I'll delete it. But unless we go till leaf, we don't know if that path is invalid because you might have positive and negative both. If we don't have a negative, then that might work because then it is not going to reduce once it satisfies.
So Praveen is saying like if we see a particular node which is a culprit who is actually making the limits go haywire, so you just need to remove that node actually. Yeah, that also makes sense if you look at the problem statement.
Yeah, I mean, that makes sense, but that makes this problem really, really difficult.
Yeah, because you have to do balancing and all that stuff. In case
exactly, you have to remove the node and you have to pick the node. Not the balancing, but what you will replace with.
Yep.
left
The
or right.
ancestor and the
But the
descendant.
question says that
Yeah, I think they
strictly
changed the
says, right?
question.
It's
Yeah, now, yeah.
root to leaf path.
Yeah. Now they made a change, I think, because I've seen this question somewhere earlier, and then there it was a lot of discussions on the same thing. But yeah, because maybe it was the way what Praveen was saying, it was that way earlier.
Yeah.
Yeah, but your solution actually is very, very explicit, so it's very easy to understand. Because I was getting confused with the last condition.
Okay.
Yeah.
I started with the null thing, but even I was getting confused. So this, when I came with this, then it became a little clear to me also.
Yep. No problem. Thank you.
I'll stop sharing.
I don't know whether it makes difference in the performance or not, but in terms of Rajendra's solution, they kind of we are reinitializing the every child to the parent again. Here we are not doing that, right?
No, I don't think we did.
No, in terms of Rajendra's solution, he was trying to if the path was good enough, then he's again assigning the same thing to the root dot left or root dot right. But in your solution, you're directly removing the node which have both left and right not
I think
sufficient.
there also we were doing the same thing. It was just the different way of doing, because there it was, if it is null, then we were putting it null. Otherwise, it was the same thing.
I don't know. Actually, he didn't share the solution though. But yeah, thing to check out for that performance, what Dilip is saying. Yeah.
Yeah. Okay.
Dilip wants to share, like.
Oh, Shashank, yeah. Yours is.
I just like compliment of what Sweta did. Like she was adding from root to right, isn't it?
Uh-huh.
I mean, like from top to bottom, she was adding. So I'm subtracting from my limit every time from top here. So 1 minus 1 will be 0, minus 2 this I'm subtracting, and just I'm checking once I reach the leaf. If I check my root dot value is less than my limit, then I'll make it to none, else I'll keep my root as it is.
Yeah.
He was adding it, I was just subtracting.
And then if both of them are null, on line 18, you are actually removing it.
Returning none, yeah, removing that
So
is
again, that's not clear to me. If my boss child, I removed my boss child, it could be possible that now it satisfies the path. Is not that the case?
Yeah, that is, I was confused a lot. Yeah. So if you use this very, efficient way of implementing the way Shashank has done, it creates confusion. So, but what Sweta had shown, a very explicit way of doing it. But this is a concise way of doing it. That's okay. And now Dilip was saying maybe how the performance is. Yeah.
I think in this also, if we don't pass, like if we check if root dot left is not null, then only call this recurse, it will become the same thing. Because we are adding, calling even if it is root dot left is null.
Yeah.
Root dot left is null. On line 17 now, you mean to say?
Yeah. So if we call only if it is not null.
Oh, okay. Oh. Well, it looks very easy when I see it over here. My only problem is what happens when I'm in the interview facing it, So if he actually ask me the same question, how do I answer him? Even if I mug up the whole stuff, it looks like that. Because he will surely ask me and see if I really understood it. Yeah. Maybe then I will do it the way Shweta does at least, so I can say, okay, this is the way it is. No problem, yeah, but maybe I'll
like
put
going to a
some
blog and seeing this one. The
print
efficiency
statements and
here.
find out, yeah. Okay.
So these are again like entire version of recursion, you can say.
Yeah.
Okay, then let's wrap it up for.
Yeah, no problem. Thank you. Thank you.
Thank